Hello, ladies and gentlemen. You guys again on today's live stream. I hope you guys had enough of today already, and let's get started. Physics first, yeah. So today we are actually going to do a little bit of revision and bring it back on the PDF file that I have sent to you guys. Might be a little here. We'll try out, we'll see what's best. Now, the junior will get the best about that. So let's get started. I hope everyone is well. If you're good, give me a thumbs up on the chat. Yeah. Oh, I'm sorry. Come on. I didn't not wanted to give you the notification, but this is really for Form 5. But if you are watching, come along, come along. I hope you can really enjoy the session and get a little bit of information from this as well. Yeah. Okay, so let's see. Let's go. As you can see in the page itself, it has a lot of things, and this is the formula sheet being given to you. Okay, in terms of over here. Okay, so this is the formula sheet being given to you, and okay, today we will be using a few types of formula, which is, I remember correctly, we will be using FA, okay, we'll be using, yep, elastic potential energy. Tenaga keupayaan kenyal sama half F. Okay. Also kita orang akan gunakan beberapa benda lagi, iaitu, oh my god, what's wrong? Right. Right. Okay, so let's go to the first question. First question dekat sini ada satu raja dan menunjukkan satu pembaris yang sudah patah. Patah ini digunakan untuk mengukur satu tissue paper box, ya. Okay, so as you can see over here, determine the length of the box. You just have to buat ukuran and then you just have to minus it off lah. Okay, so this answer is pretty simple. 18.5, you dapat 18.5 cm, you kena tolak 2, kamu akan dapat 16.5 m. Okay, so that's all the answer. Pretty simple as that. I'm not going to go very far on this one. Okay, let's go to the next one. So, nyatakan satu sebab mengapa kotak tersebut tidak diukur bermula daripada sifar pembaris itu. Can I say that? Maybe. Okay. Yep. You can say that also. But if you want a more physics way of answering it, it can be sebab pembaris itu mempunyai ralat sifar. Okay. Dia mempunyai ralat sifar. It has a zero error over. Okay. Dia mempunyai ralat sifar. Describe one simple method to avoid parallax error. Nyatakan satu kaedah yang mudah untuk mengelakkan ralat parallax semasa pengukuran diambil. Memastikan mata berada di tegak atas skala bacaan. Okay, so the few words is mata berada tegak atas skala bacaan. Okay, so these are the few keywords that we will be actually having. See, ya, mata tegak skala, di atas skala. Alright, so that's all for the question. I think it's pretty simple. Let's go the next one. Nyatakan kejituan pembaris tersebut. State the accuracy. Accuracy itu jangan lupa, the word accuracy represent satu benda. Accuracy, kejituan, menunjukkannya bacaan terkecil. If we look back at the question at the baris itself, you will get the answer as 0.5 centimeter. Okay, right? I get 0.5 centimeter. Okay, are we good? Okay, let's go. So the next question is Raja 2.1 menunjukkan Raja 2.1 menunjukkan who's a gun? Why did my voice why? Raja 2.1 menunjukkan graf. This is crazy. Okay. Yeah, I need a better point. Okay, Raja 2.1 menunjukkan graf pemanjangan tiga spring. Okay, PQ dan R. Gaya. Okay, you have PQR. All right, let's zoom it smaller. Look at it. Okay, PQR. Right. So the next one. Hold on, give me 1 minute. I don't know why, but yeah, yes, right. Okay. So you have PQR, alright, and then satu hukum menyatakan bahawa pemanjangan sebuah spring adalah berkadar langsung dengan daya dikenakan jika had kenyal tidak dilampaui. Nyatakan guys. You guys have any idea? You guys have any idea? Hey, hukum hook, okay? Hukum hook. H-O-O-K-E, okay? Hook. Now, the next one. Dekat graph, mark X at the elastic limit for spring P and Q. What is the elastic limit? Is that the point where the spring start to bend. Okay, so you need to mark X. Okay, so I mark it over here, X. So simple that mark the X point. Okay, I think there's a little bit of delay over there from what. Yeah, it's because my CPU is not quite processing very. Let me change a US. Okay, maybe this USB. Computer dah lama dah. Stop more. Okay. The spring stores energy. Spring itu menyimpan tenaga. Okay, you get the 2x, alright. I'm sorry, I go back to that page a little bit. Okay. 2x is here where the spring starts to bend. It is your elastic limit. Pretty simple. Okay. Let's go. On the graph, mark X. Done. Spring menyimpan tenaga apabila diregang. Hitung tenaga yang tersimpan dalam spring R apabila pemanjangannya ialah 8 cm. Okay, pemanjangan 8 cm from the sheet that is being given to you in front, dia menyatakan tenaga adalah sama dengan half Fx. Okay? Dan jangan lupa kalau dalam situasi ini, walaupun tidak digunakan, I will do a little bit of revision with you. F ini adalah sebenarnya sama dengan Kx. Okay? And then in the end, kadang-kadang kamu akan dapat half Kx square. Apabila saya ambil Kx ini digantikan masuk ke dalam the F. Alright? So both of these works as a formula. Okay? Okay, my phone don't usually lag, but slowly it starts lagging. That actually. And today it popping up. Okay. Oi. Wireless. Okay, so let's not talk too much about that. Hitung tenaga yang tersimpan dalam spring apabila pemanjangannya adalah 8.0 cm. Okay, we will use back this formula. E equals to half Fx. And then we will go back to the diagram tadi. Okay, remember it is talking about 8. And then the next one is go all the way up. Okay, go all the way to the side. Right, I have 60 Newton, then I have 8 centimeter. Okay, let's go down. Hitungkan tenaga sama dengan half. Okay, say Newton and 8 cm, jangan lupa 8 you have to times 0.01, or this one is actually you straight convert in 0.08. Okay, so you get the answer, you calculate half 30 times 0.08, 30 times 0.08, 2.4. So that's pretty simple question. All right, we'll take a hey, good, wrong. Okay, so let's look at the next question. Question 3. Question 3 ini adalah bab radioaktif. Okay, bab radioaktif dan soalan ini mewakili satu reputan radioaktif. So the keyword here is reputan. Okay, reputan radioaktif yang berlaku secara spontan. And then let's look at it at this question. Namakan reputan radioaktif tersebut. Namakan reputan radioaktif. Reputan lah. Let's do back a little bit of revision. Reputan ada 3 jenis. Reputan first one is reputan jenis alpha. Kemudian jenis beta. Dan reputan jenis gamma. Okay, ada 3 jenis. Dan ini adalah reputan alpha. So you have to write reputan. Okay, so reputan alpha is that you will produce a alpha particle that looks like a helium nucleus. It is a helium nucleus that looks like a helium nucleus, but it's not a helium atom. Okay, bukan sebuah atom helium. Alright, the next one, let's go. Mengapakah reputan radioaktif tersebut berlaku? Must be the reason. Let's look back on top. 226 Ra ini disebabkan dia tak stabil. Okay. So, dia sebab nukleus berat yang tidak stabil. In SPM, the keyword over here is tidak stabil. Okay, that is the keyword in SPM. And it is very important to observe all these keywords. Even if you write nucleus berat, doesn't give you any mark. The keyword tidak stabil must be there. If you okay. Jadual 3 menunjukkan jisim atom bagi 3 unsur. 3 sahaja. Okay. Radium, radon, helium, dan blah blah blah. Okay. And we today going to talk about a few things. This is under penggerakkan tenaga nukleus. Okay, so very easy. First one, it has already guided you through calculate the mass defect. Okay, dalam nukleus always yang kat depan always yang kat depan itu adalah lebih berat daripada yang jumlah kat belakang. Okay, this one is always more berat. Okay, this guy over here is always more berat. So let's go. Dia lebih berat. So you have your RA, which is 226.025. So you have to have your title. Cacat jisim sama dengan 226.025. 226.025 minus yang semua kat belakang punya 222.018, 4.003. 222.018 plus 4.003. Okay, so we have all these things. You just do the math over here. So the answer would be 0.004. But this is not the answer. This is your U. Don't forget, dia kata dalam kilogram. Okay? So you have still got another step. You have to convert it into kilograms. Yeah. Okay. So you take your 0.004, you have to multiply by your value tadi, 1.66 times 10 to the power of minus 20, okay, times 1.66 times 10 to the, okay, you have this, have this 4.004 times 1.66 10 to the power of 8. Okay, so you will get the answer as 6.64 times 10 to the power of 30, okay, kilogram. And then you use this answer in your next question. In SPM, saya nak bagi tahu jawapan kamu ini, first point, ini the second point, and then jalan kerja mungkin the third point. So you dapat either one, you either dapat either one betul, kamu akan dapat markah. Okay. Calculate the energy released from the radioactive decay. You have to use the formula E sama dengan mc square. E sama dengan mc square. Your m is your 6.64 times 10 to the power of minus 30. Okay. Times bagi kamu speed of light. Speed of light cari kat hadapan. Hadapan I hope, wait I confirm kejap hadapan ada tak dia punya formula dia. Okay. Hadapan ada tak nilai dia? Ada. Hadapan nilai dia ada di belakang sekali. You can check out your PDF file, dia ada di belakang sekali. Hal laju cahaya times 10, 3 times 10 to the power of 8. Okay? Jangan lupa square. Okay, make sure you type this into your calculator very carefully. Do not get any mistakes in your calculation. Alright? And then we're good. We're good to go. I'm not going to talk about the answer because if I want to talk about the answer, I have to calculator and calculate. So I'm not going to do it. Okay? So you guys get the answer. Alright, so now we are at question 4. We are at question 4. Okay. Raja 4E menunjukkan loyang berjisim 100 gram direndamkan dari dalam air mendidih dalam jangka masa yang lama. What it means by jangka masa yang lama, for a long period of time, is dia beri chance pada kedua-dua bahan ini interact a little bit and each other have a transfer heat to each other for a long time. So in the end, both of this temperature will be the same. Okay. Loyang kemudian dipindahkan ke dalam bikar mempunyai air berjisim 100 gram pada suhu bilik 30 degrees Celsius dalam B. Okay. State initial temperature brass. Initial temperature of the brass, what is it talking about is that what happens before bola loyang tersebut direndamkan ke dalam air panas. So, suhu dia mesti adalah sama dengan suhu bilik. So, it is 30 degrees Celsius. Okay. Then the next one, what will happen to the temperature of the brass and the water subsequently? The next one is suhu loyang akan jatuh, suhu air akan naik. Loyang menurun, suhu air meningkat. This both is good enough. Okay, if you want, you can actually add on another point, but it's a little bit not necessary. You can add on the next point sehingga kedua bersuhu sama until the next two achieve the same temperature. That is thermal equilibrium lah, huh? Okay. After some time, the system reach a state where the temperature are the same. Suhu loyang dan air panas itu menjadi sama. This one is called the thermal equilibrium, yaitu keseimbangan. Okay, very good, very good. Okay, table 4B. Jadual 4B menyenaraikan muatan haba tentu loyang dan air. Okay. Based on the data given, calculate the temperature referred in C1. Okay. What they want to calculate. So just remember, loyang 380 gram, air 4,200, dan kedua, loyang tersebut is 30, loyang tersebut 100 gram, air tersebut pun 100 gram. Okay. State 1 assumption made in C. Okay. What? Oh, C1. Okay, C1. Suhu apa yang berada di C1? Okay. So we know over here, transfer, we have to separate into two parts. Okay, so first one is daripada loyang di bahagian loyang. Second ialah di bahagian air. Right? Loyang sana suhu naik. Air sana suhu turun. Okay? That means sini haba yang dia contain naik. Sini haba yang dia contain turun. Okay? Tapi kehilangan haba daripada air dengan haba yang diperoleh oleh loyang tersebut adalah sama. Okay? So that is the first very important key point that we know over here. Very important point over here that we know. Okay, and then from here we are able to calculate MC theta adalah sama dengan MC theta. What are you talking about, sir? MC theta adalah sama dengan MC theta. Jadi inilah theta ialah perubahan suhu yang dialami oleh loyang. I label it as 1. Yang dialami oleh air. Label it as 2. Okay. So M loyang 100 gram. I put back 100 gram. Okay. M air 100 gram. I put back 100. C loyang. In the question itself, it is stated 380. So I put 380. Okay. Air. In the question it says 4,200. So I put back 4,200 lah. Okay. Right. So if we are all okay over here, we can have a look, okay? $4,200. Okay, so data satu. We know loyang ke increase in temperature. So, saya tahu bahawa suhu akhir data tolak 30. Increase in temperature. Suhu akhir, suhu akhir, suhu awal. Okay? And I also know dekat sini air kehilangan haba. So it is suhu awal air is 100. Okay? Tolak data. Okay? So as you can see over here, then you need to do a little bit of math. Can I straight this thing? Okay. So, yep. Just need to work out the math and find out what is data. 100 and 100, you can straight cut it off. Gives you less headache. Okay. So you're left with 380. So you're left with 380 data minus 380 times 30 is probably 11400. Okay. And then it's gonna be 420,000 minus 4,200 theta. Okay. So you work out the math and yeah, you get to that. So all good. Hey, fantastic. I'm having 1, 2, 3, 5. Seconds B. Hey. Ooh. No second. This is like pure second delay. Hold on, not the things that is really. Hey, let's go, baby. Let's go, baby. Ah, you see, every time after I put it in the goal delay, time I start this. Just sign to change computer. Okay. Still one assumption, nyatakan satu andaian yang dibuat dalam C2. You have to have the assumption. Assumption is very important. Tiada kehilangan haba. Purpose kita. Okay, very good. I think I know why. It's because my queue is running very hard. Load my. Okay. All right. Here we are, 4 questions, and I think it's time that stop right here. And for a reason, first is I don't think this is functioning very well. I do not want to spend a lot of your time because the experience is just not nice. Okay? And also the purpose is I do this session so you can kickstart yourself a little bit into learning and also kickstart myself a little bit so that I can teach a little bit more. And we'll leave this question to the next session of our live stream. See you guys around, guys. Bye. If you guys got any questions, please feel free sending the questions, blast in the questions. I will get try my best to answer those questions. Well, someone already asked me for questions. Hopefully, it will come in email really soon. DM me, guys. DM me, guys. I will guys on your journey to SPM. Your journey, guys. Get that. Guys around. Ciao.